Hey, good morning, good afternoon, good evening, happy Monday. New week. It's week 7, guys. We are getting there. We have 3 weeks left and we're done. That maybe sounds like it's long, but it's going to go really quick. So wherever you're at, man, I just want to encourage you. Keep plugging, don't quit. Keep going. You can do it. We can do it. We're almost done. Let's finish strong. Let's go. Today, I just want to talk through a couple different ideas on acids and bases. If you remember last week, we started a new unit on acids and bases. We talked about what is an acid, what is a base. Our chemistry live, we looked at 10 different household items and said, hey, is this an acid? Is this a base? Is this an acid? Is this a base? One of the things I want to show you is that just like most things in our world, things aren't always clear cut, black or white, this or that. It's not like that's an acid, that's a base. And things are, and you can test them and find it out, but the way that people define acids and bases change. You know, if I were to say define love, tell me what love is, you could do it. And then if I went to your mom and said, tell me what love is, they could do it. And then if I went to your lover and said, tell me what love is, they could do it. But I bet if I brought them together, those definitions would all be a little bit different. They would all describe love. They would all describe the same emotion, commitment, whatever you describe it as, but the definitions are a little bit different. Well, acids and bases are the same thing. So there's 3 different definitions I want to show you that have led us to think of acids and bases as we do today. Okay, so I'm going to go through this. I'm going to try and go fast. But there is a sheet that you can fill out as you go along. Again, you can write it on paper and then take a picture. Great. You can put it on the Google Doc and type it in and do the split screen thing as we go along. Great. However you want to do it, but fill that in, get that done, turn it in, click the button, you're done for today. Okay, pretty straightforward. All right, sweet, let's go. So I want to go through this. I want to make sure I'm set to go. All right. Let's rock. So there are 3 different definitions we're going to look at today. Okay, there's what's called savant. I think that's how you pronounce it. I know his last name is Arrhenius, so we'll stick with Arrhenius. Way back in 1887, there's another guy named Broadstedt and Lowry. These are 2 gentlemen. One's a Danish man, one's an Englishman. They independently proposed the same definition, so they both separately came up with the same idea. So they're given that same credit. And then there's Gilbert Lewis, who's an American back in the 1920s, so 100 years ago. These 3 guys have led our understanding and our belief of acids and bases. So we're going to go through those 3 different definitions today, okay? Maybe if I can. Okay. So the first guy, Arrhenius, so this is the oldest gentleman. He looked at acids and bases, and he looked at what was being produced. Okay, so he said acids produce hydrogen ions. And notice again, it doesn't just say hydrogen. It says hydrogen ions, and that's that plus. So if you take an acid and place it in what he called an aqueous or aqueous solution, that means you just dissolve it in water. Okay, if I take an acid and dissolve it in water, I'm going to get hydrogen ions. I'm going to get H pluses. So for example, if I took hydrochloric acid, put it in water, I'd have HCl, and the AQ after just tells you it's aqueous. It's been dissolved or diluted in water, okay? Look what happens. When that happens, it produces 2 things. It produces H plus ions, right? Hydrogen ions, and Cl minus ions. That's what happens. It dissolves into those 2 things. So what he found is that's not just true of hydrochloric acid. He said, you know what? That's true of all acids. Now bases, on the other hand, he found when he put those in aqueous solutions, they produce what's called hydroxide ions. Now hydroxide is one of your polyatomic ions. What is it? It's OH. It's an oxygen stuck next to a hydrogen. But again, notice it's an ion. It has a negative charge. So for example, if I had a base and I put it in water, if we use sodium hydroxide at the bottom, it would dissolve, it would dissociate and pull apart into sodium ions and hydroxide ions. And he found that true of every base. So he said, you know what? Bases make OH minuses. Acids make H pluses. And that was his definition. He said, you know what? That's it. I figured out what makes an acid and what makes a base a base. Okay? So that was the very first definition. Now, there's a little problem with that. And he was right, but there's a problem with that. Okay? Some bases do not contain OH. So if I have NH3, if I have Na2CO3, ammonium and sodium carbonate, when they dissolve into water, look at this one, there's no O's. Look at this one, there's no H's. So they cannot form OH minus. And so most of the time that worked, but it wasn't like, hey, that always works. And so we needed a new definition that not only explained that, but what about these other weirdos that were kind of the exception? Okay. Now, along came two guys, Bronsted and Lowry, and they came up with a different definition. They said, you know what, let's quit looking at the bases as OH minus and the acids as H plus. What they found is all of them, whether they're acids or bases, all of them have hydrogen. All of them have that H. Okay? And so what they said is they don't have an H, they still can gain an H. And so what they looked at is they looked at hydrogen ion as donors or as acceptors. Okay? So look at the example below. If I have HF, hydrogen and a fluorine, okay, that's fluoric acid, hydrofluoric acid. If I add that to water, I'm going to actually produce these two things, H3O, which is called hydronium, with a plus on it, so it's an ion, and fluorine with a minus, which is a negative ion. Okay? Now, if you look at that, well, what happened? Well, if I look at the left side, I have HF. On the right side, I just have F. This HF lost the H. On the left side, I have water. On the right side, I have H3O. What happens there is H2O gained an H. So one of them was a donor, HF, and one of them was an acceptor, H2O. And so I have one of them as an acid and one of them as a base. Okay? Now, acids can have more than one hydrogen that can be ionized, that can be charged. Couple quick definition terms. If you only have one, we call it a monoprotic acid. Mono means one. If it has two, you have a diprotic. That means di means two. 3 is tri. 4 is poly, 4 or more. Okay? So it's not always right. We go back to this example. One hydrogen become ionized. One hydrogen became a plus. So this is a monoprotic acid. But there could have been 2, there could have been 3, there could have been 10. Okay? And so that's just a couple more words there. All right, now, speaking of words, and I know I'm getting wordy, and we'll go back and we're going to talk about this tomorrow, this conjugate acid and conjugate base. What I want you to see is this goes back to Bronsted and Lowry's definition. Okay, so if I were to give you an equation that looks like this, okay, HA plus H2O. Now, in this case, A just means acid. Tell you it's an acid. It doesn't matter even what it is. But the acid, remember, is the donor, right? Acid is the donor. It donates. The base is the acceptor. All right. What happens is when the acid donates and loses this hydrogen ion, it becomes a conjugate base. It loses, and so now after it loses the H, it goes from being an acid to a base, right? This guy's rich. Think about it. People who donates, right? If you're in a fundraiser, let's say you're on the volleyball team and you get a fundraiser and they tell you got to raise $200. You're like, ooh, $200. You are not going to go down the street and find the house with all the broken windows and torn down shutters and the yard is all janky. You know, at that house, they just maybe are great people but don't have much money. You're not going to go knock on their door and say, would you be willing to donate $200? They'd say, yeah, I don't have it, but that sounds cool, right? You're going to go to the really nice house that has the BMW in the front, that has, you know, the cars and the buses or boats and all the toys, and you're like, they have money. They not only are going to be willing, but are going to be able to donate. Okay, so if you look at acid, it starts with an H. It has hydrogen to give, but now when it gives it away, if it gave all of it away, right? If you rang on that door of that mansion and said, you want to donate? They say, yeah, that's a great cause. We'll give everything we have. Well, crud, now they're poor, right? If they give it all, they're poor. So they would go from rich to poor, or in this case, they would go from an acid to a base. Now, we don't just call it base because they used to be rich. We call it a conjugate base. They've become poor. They've become a base. In the same way, if the base who starts out poor takes more, they become rich. So the base, in this case water, becomes an acid. Now they have an extra H. We call them conjugate acids. Okay, so here's the definition. Conjugate acid is the particle that formed after receiving the proton, after receiving the H plus. A conjugate base is what's left after it's donated. So this one became rich. Now, we're not talking about money, but it became rich in H pluses. Conjugate base became poor. What did it become poor in? Poor in H pluses. They lost, they donated, they gave it away, so they went from an acid to a base. Okay, and we're going to talk more about those tomorrow. So here's a real common example. Okay, I have ammonia and water. If I mix those together, I get ammonium and hydroxide. Okay, well now look at it. Which one is the donator? Which one is the acceptor? Right, I look at it, I say, well, okay, I look at the left, I look at the right, I look at the left. What donated and what accepted? So right away when I look at the right, I have NH4, right? Well, I didn't have an NH, I had an NH3. Ooh, it accepted, it took an H. So remember the definitions, if they accept an H plus, they're a base. Okay? Water, so this base became an acid. Water became that. It lost an H. It was the donor. And so when it donates and it loses, it becomes poor. Okay? It becomes a conjugate base. Okay, and we'll do more with that tomorrow again. Now, one quick note, water can do both. It can be an acid, it can be a base, because remember from Chemistry Live, water's neutral. It's equal acid and equal base. It's not either one, it's both. So because it can be acid and base, we call it amphoteric. Okay? Amphoteric water can be either one. So when you look at water, you can say, ooh, that's an acid, ooh, that's a base. You don't know. It could be either one. All right? Almost done, guys. I know that's a lot and maybe it doesn't make all sense, but we'll break this down a little bit more. There's one more definition, and that's Lewis. He didn't like this idea of H's being accepted and donated, and he actually looked at it in different ways. You know what? Yeah, sometimes it is H's, sometimes it is that hydrogen, but he thought a more general definition would be accepting and donated pairs of electrons. Okay. Now, again, that very well could be an H. But here's another example. He looked at this and said, okay, if I have NH3, which is ammonia, excuse me, and we add H plus to it, I get NH4 plus. Okay, I get a donated, it doesn't just donate H. Yes, this H goes here, but what actually gets donated and accepted is the pair of electrons. And I'm not going to get into the details of that. I just want you to see there's a different way to look at it. Okay, that's all I want to do. That's maybe a little deeper than we want to go. So real quick, here's our three models of acids and bases. Arrhenius said acids produce H pluses, bases produce OHs. Okay, produce H pluses, produce OH minuses. Bronsted-Lowry said, no, acids are H plus donors, bases are H plus acceptors. And Lewis liked that donate accept thing, but they looked more at electron pairs rather than hydrogen ions. Okay? So why are we looking at all these definitions? Maybe sometimes that feels like it's more confusing, and it can be, but I want you to see it's not just as clear cut as it's this or that. There's a lot of different things that certain people believe, oh, this makes this an acid and this makes this a base. It expands our definition of acids and bases. Just as you get older and you learn more about life and love and all those things, if I were to ask my 3-year-old, what's love? I probably should do that. Maybe I'll do that for my video tomorrow. He'll tell you what it is. And I ask my 5-year-old, he'll tell you what it is. And my 15-year-old, he'll tell you what it is. And they'll probably all be right. But my definition is probably a combination of all of those because I have more life experience. And so I want you to see the combination of all those things to have a better understanding. Okay, so guys, that's it. Hopefully that sheet's filled in. Again, you can do the Google Doc, or you can do it on paper. Click it, turn it in, you're done. Boom, way to go. That was about 20 minutes. Was right on pace where we wanted to be. Hope you have an awesome week. Love you, miss you. We'll talk to you later, guys. Bye.